Throughout the course, we've been discussing how GeneXus determines the database structure from the transaction design. We've also seen that it automatically makes referential integrity checks, and to do so, it uses the primary and foreign indexes that it creates in each table. Now we'll look at a case study to analyze how GeneXus normalizes the database and determines the table structure from a given transaction design. Let's start then with the concept of a normalized database. What does it mean? It means that there are no duplicated data, no redundancies. Secondary attributes are present in a single table. Inferred attributes are not stored. And the only attributes that can be included in more than one table are primary keys, since there are also foreign keys in other tables. Let's look at the case study then. Consider the following transaction design, where we can see that we're modeling countries, trips, or tours to a certain country with a tour guide in charge, and the clients who can take several of these trips or tours. The first thing to remember and keep in mind is that we cannot look at each transaction independently. We must analyze the entire data model. Each transaction generates an impact on that data model. Note that country and tourist guide transactions are simple, single-level transactions, each with its own identifier and name, and without any foreign keys. Each one then has its primary key and a secondary attribute. Therefore, we already know that from them, GeneXus will create the tables country and tourist guide with the structure shown here. The country table has country ID as the primary key and country name as the secondary attribute. Over this table then, GeneXus will create the primary index by country ID. Remember that GeneXus automatically creates the primary indexes to control the uniqueness of the primary key and to efficiently perform the reference integrity checks. The tourist guide table has tourist guide ID as primary key and tourist guide name as secondary attribute. In this table, GeneXus will create the corresponding primary index by the tourist guide ID attribute. Let's take a look at the trip transaction. It has trip ID as a primary attribute and trip date and trip price as secondary attributes. Then, tourist guide ID is the foreign key in this transaction, and tourist guide name is inferred from that value. There's a one-to-n relationship between tourist guide and trip. Something similar happens with the country ID attribute, which is a foreign key here, and country name, which is inferred from that value. There's also a one-to-n relationship between country and trip. We already know that the inferred attributes are not stored because GeneXus gets their value from the corresponding foreign keys. So, what will be the structure of the table associated with the trip transaction? Its primary key, trip ID, and the attributes trip date, trip price, tourist guide ID, and country ID. If we now think about the indexes, which indexes will be created by GeneXus over the trip table? The primary index by trip ID, and the foreign indexes by country ID and tourist guide ID. This means that, for example, when inserting a trip, the primary index by trip ID will control the uniqueness of its value. In other words, that there is no longer another trip with the same primary key value. The primary index by tourist guide ID in the tourist guide table will allow performing the referential integrity checks by making sure that the value of the foreign key tourist guide ID indicated in trip previously exists as primary key in the tourist guide table. The same control will be made by the primary index by country ID defined in the country table. It'll check that the value indicated here previously exists as the primary key in country. On the other hand, if we try, for example, to remove a tour guide through the tourist guide transaction, the foreign index by tourist guide ID defined in trip will check that there's no tour registered with this tourist guide ID value. If there is one, GeneXus will warn that there are records in trip that have in tourist guide ID the value we're trying to delete, and it won't allow deleting it. Now let's look at the customer transaction. It's a two-level transaction with trip ID as primary key of the second level. This indicates an end-to-end relationship between customer and trip. And we already know that from this transaction design, GeneXus will create two tables, customer and customer trip. But let's focus on the first level of the transaction. Customer ID is the primary key. Customer name is the secondary attribute. And customer trip's quantity has an associated calculation. That is to say, it's a global formula. And we already know it's a calculated attribute that's not stored in the database. Let's focus on the second level now. Trip ID is its primary key, but it's also a foreign key. And we see trip date, trip price, country ID, and country name. If we look again at the structure of the trip transaction, these attributes are present there. Therefore, all of them obtained, inferred, from the value of their primary key, trip ID. This means that now in the second level of customer, these attributes will be inferred by the trip ID value. So, country ID was a direct foreign key stored in trip, and now is an inferred foreign key on this second level of customer. What happens with the attribute customer trip miles? It's a secondary attribute of this level. So how does the structure of the tables based on the customer transaction look? The customer table associated with the first level, with customer ID as the primary key and customer name. Remember that the attribute customer trips quantity, when calculated, is not saved in the associated table, and then the customer trip table associated with the second level of the customer transaction, with the pair customer ID, trip ID as primary key, and the secondary attribute customer trip miles. As for the indexes, in customer, the primary index by customer ID will be created. In customer trip, its corresponding primary index will be created by the attribute pair customer ID, trip ID, and then the corresponding foreign indexes by trip ID and customer ID. Note that no index is created on this table by country ID, because as explained before, in this table, it's not a direct foreign key, but inferred through the value of trip ID. In this way then, we've analyzed that from this transaction design. GeneXus creates this normalized structure in the database.